There are few light aircraft in the skies today that are as distinctive and admired as the Mooney M20. The first thing that grabs the casual observer is the aircraft's stunning looks and very unique appearance. That one-of-a-kind tail combines with aerodynamic fuselage and wings to give this aircraft its renowned high performance. And together, these traits have been luring pilots to the Mooney for over 55 years. These design characteristics are definitely no mistake, having been brilliantly crafted by Al Mooney and his engineering team to obtain the maximum performance available from a single-engine, four-seat general aviation aircraft. What resulted from the Mooney Aircraft Company's efforts was an aircraft featuring a low-wing, retractable tricycle landing gear and powered by a 150-horsepower Lycoming piston engine, offering a maximum speed of 149 knots. This original model, the M20, and the subsequent M20A both featured fabric-covered wooden wings, but were otherwise similar to later designs. Over the years, there have been no fewer than 14 variants of the Mooney that offered varying degrees of performance, along with different aircraft systems and cabin configuration options. These variations most notably included 3 different cabin lengths, known as the short body, medium body, and the long body, which provided different comfort levels, as each still only offered seating for 4 people. Internally, the biggest improvement occurred in 1969, when Mooney made electrically operated flaps and landing gear standard across its product line for the first time. Prior to this, electrically operated gear was only an option, resulting in many of the early model airplanes having manual controls for both flap and landing gear extension. Based on the high-performance figures that this amazing airplane offers, it should come as no surprise that it is not the type of aircraft that a flying school will entrust to a new student pilot during their initial training. It is, however, an excellent airplane to teach the experienced student the intricacies of handling a complex single-engine aircraft. This would normally be considered as a second or third step on a student's path to flying an aircraft such as the twin-engine Piper Seneca. The Mooney offers the challenge of significantly higher speeds compared to the Cessna 152 or 172 that the student has been accustomed to flying. When you also consider the complexity of learning to operate an airplane with a variable pitch propeller and a retractable landing gear, the step up is definitely significant and not to be taken lightly. But there are no such worries on this flight. We are about to experience what it's like to fly the Mooney M20C in the experienced and capable hands of Arne Krutoff. Arne is the president, CEO, and chief pilot of Florida Flight Training Center, operating out of beautiful Venice Municipal Airport in Florida. Arne's logbook includes everything from gliders in his early years to heavy multi-engine commercial jets, and his passion for aviation and flight training are obvious to all those that know him. In the training seat today is Sarab Manga, a Florida Flight Training Center student with lofty goals of flying commercially in the near future. He has soloed in the Cessna 152 and Cessna 172 and is now taking the next big step up to the Mooney. Today's aircraft is Mooney M20C November 466 Tango Charlie, which made its first flight in 1965. The M20C was the most highly produced of the series and was offered from 1962 to 1978. This model was referred to as the Ranger for marketing purposes, although that title is not commonly used day to day. Most people simply choose to call it the Mooney. The M20C was the last of the short bodies to be produced. The airplane's highly tapered fuselage seems to almost wrap around the occupants, giving the sensation of driving in a classic sports car, yet another reason for pilots to fall in love with this aircraft. The details of the original design process become obvious upon closer inspection of the aircraft. Everything from the recessed fuel caps to the flush riveting used on sections of the wing point to the goal of maximizing the aircraft's speed. The Mooney's tail is, without a doubt, the airplane's most distinctive feature. Although it appears to slope forward, this is just an illusion created by the angle of the rudder's trailing edge and the leading edge of the tail being perfectly vertical. Another feature that may be only known to those close to the Mooney is that the entire tail is hinged and everything, including the elevators, pivot in order to trim the aircraft. This eliminates the need for an elevator trim tab and adds another mysterious feature to this mighty little aircraft. Venice Airport was built in the 1940s as a military training base during World War II, and after the conflict became a civilian airfield. The airport boasts an ideal location right on the Gulf of Mexico and is bordered by a wildlife preserve, a golf course, and Florida's famous white sandy beaches. It is about 20 miles from Sarasota Airport to the north and 50 miles to Fort Myers Airport to the south. This offers student pilots local uncongested training airspace, as well as controlled airspace just a short flight away to help develop radio communications and instrument approach skills. The airport has two 5,000-foot crossed runways offering 4 distinct approaches. They are runway 1331 and runway 422, each measuring 150 feet wide. There are over 230 aircraft based at the airport, and annual movements vary between 165,000 to 175,000 per year, which averages over 450 per day. Air Utopia welcomes you on board the Mooney M20C for a personal flight training experience as we witness a student pilot's progress as he moves up to the high-performance, complex single-engine aircraft.
Today is the day that we transition to the single-engine complex aircraft, the Mooney. The Mooney is like an old Jaguar cars under the airplanes. You sit very low, you're almost laying in your seat, and the aircraft is very rapid. It's a quickly accelerating aircraft. Eventually, when we are leveling off at altitude, you will have to expect an airspeed somewhere around 140 knots. The 172 was giving you 115, 120 knots maximum speed. Okay, so the airplane is going to be faster. Also, the airplane is going to descend faster and fly actually nicer again. It's a nicer flying aircraft. There's some things on this airplane that are really unique. Number one, not very unique, but something that you're not used to. The gear is retractable. This particular gear is manual. There's a big steel pipe that you have to take out of a lock and push down to raise the gear. Initially, this is going to be very awkward for you to get used to. If you want to lower the gear, you have to take this steel pipe out of the lock, move it up, and the gear has to go into the wind, and you do have to use a little muscle here and lock it back into position. So that's the landing gear. Now the flaps, they come down this time not with an electric motor. Instead, you're going to close a hydraulic valve and you're going to start using a crank to lower the flaps. There's a little flap indicator. It's not in the best position. It's difficult to see. So I recommend that we also look outside and visually check exactly at the flap position. Okay. Something else that's very unique on this airplane is that when you do your pre-flight and you do your walk around the empennage, you're not going to find an elevator trim. There's no trim on this airplane. And the reason why is because the entire empennage itself, including the vertical stabilizer and rudder, moves forward and backward.
Okay.
Okay. When you look at the Mooney and you study the aircraft, everything you look at it with the eyes of an engineer that tried to make the aircraft as smooth and as slick or as aerodynamic as possible to get the best speed for the least amount energy that goes into the engine. They feel a little crampy, like a little sports car. You know, you feel like you don't have the space anymore. But once you get used to how they fly, you will enjoy this aircraft. The landing gear has bungees. It feels a little awkward during takeoff and landing, and it doesn't allow the same impact that we're used to on the Cessna 152 and the 172. So you're going to have to fly the airplane a little bit lower to the ground. We cannot afford to stall high above the ground. And the airplane also has a trend sometimes to porpoise if the nose is not kept up. So after initial touchdown, make sure you don't relax on the yoke. You know, keep the yoke in your stomach and keep that nose up so we don't start porpoising.
Okay.
There is a maximum gear extension speed, operation speed, the speed at which we can operate the landing gear. Of course, the flap speeds are going to be different this time. The propeller now, it's a constant speed propeller. What that means is that you can change the blade angle. It's much like a bicycle. You change your gear before you go up the mountain. If you don't change the gear first, you're going to put a lot of stress on your knees and on your ankles and on your muscles. Before we add power, we're going to always change the gear or go to a higher RPM, lower pitch attitude.
Okay.
All right? Now, reducing the power, it doesn't really matter. You're not going to hurt the airplane. Can you think of any time during our flight where we have to go to instant power?
Well, if you execute a miss or go around.
Perfect answer, exactly. In case of a necessary go around, we would need to go to instant power, and that is a time we don't want to have to worry about a propeller, a pitch or propeller setting. Okay, so out of precaution or just to be ready on the base leg or on the final, you always move your props forward.
Okay.
Right? So the mixture is forward, the props are forward in case the power needs to go forward. The go around is first the pitch change backed up with full power. Then we raise some of the flaps, the gear, and with positive rate, the remainder of the flaps. Let's go to the aircraft, do the pre-flight, and then let's go and fly the Mooney.
Alright.
Okay.
The flight school is about 22 miles south of Sarasota, Bradenton, between Sarasota and Fort Myers. So we have two airports right around us for good practices of control towers and approaches when we were doing our instrument flight.
It's back until 5:30, so it's available for 5:30. I don't know how to
Municipal Airport. Automated weather observation. 1355 Zulu weather. Wind 120 at 3. Visibility 10. Clear below 12,000. Temperature 32 Celsius. Dew point 27. Altimeter 3015. Remarks. Density altitude 1,700.
Venice Municipal Airport is in a noise-sensitive community. Runway 22 is the noise abatement and calm wind runway. The traffic pattern for runway 13 is right hand.
All right, so let's start with the Pre-flight inside the cockpit.
Alright, check master switch on. Check. Check gear is down with the green light. Check.
Okay.
Check fuel quantity.
We have no fuel according to these gauges. So we
Alright,
need to put some fuel in this
refuel.
airplane.
And let's put the flaps down for the check. Alright, the first item on the pre-flight checklist is check condition of flaps.
Okay.
Let's check the condition. Go down, check the connections. 1, 2, 3, 4. Nuts and bolts seem to be in place, so they look good.
Okay.
Let's move
Very
on
good.
to the aileron. Check the functionality.
Yes. Notice how the deflection of an aileron on the Mooney is very little.
Yes.
Okay. That's normal.
Nuts and bolts seem to be in place.
Okay.
No nicks and cracks.
We're not gonna lose our ailerons today?
No, definitely not. Navigation light seems to be fine. Alright. The next item is checking the leading edge for any nicks and cracks. Seems pretty clean, smooth. Next item is to check the fuel in the right tank.
Fuel quantity?
Yes, sir.
Visually check.
Next item is to sump tank.
Okay,
For
we
this.
need a sump.
I have the sump right here with me.
You have the sump. Let me hold the checklist for you. No water,
No water,
no rust,
no rust,
Just-
no sort of dust particles.
just good fuel.
Fuel seems to be clean. We can put it back in the tank.
Okay.
Alright,
Your checklist?
check. The next checklist item is to check the oil.
What is the minimum quantity?
Is
you want?
6 quarts and the maximum should be 8.
Okay. Looks like we have a little over 7 quarts.
Yes, sir. So we're good to go for today with the oil. Calling. Secured. Check. Next item is to check the prop for nicks and ticks.
Okay, notice today that we have a 3-blade prop.
Check. Condition seems to be fine. No cracks, no nicks, no ticks on the props.
Okay.
Let's check this one. Seems fine. Next item is to check the air vents to see in for any blockages. The air filters seem fine. Landing light seems fine. Check.
No bird's nest here.
Definitely not.
Okay.
The alternator pads seem to be fine.
This is your oil cooler.
And this is your
There's
air
no
vent.
obstructions there. That's for fresh air that goes to the engine.
Next item is to check the nose gear. Checking the nose gear. Seems good. Nuts and bolts in place. No leaks.
Okay.
No obstructions in the nose gear door.
Okay. Looks good. Tire. We have a good tire.
Good air pressure.
All right.
Left wing. Check the fuel quantity in the left wing.
Notice also how these fuel caps are flush on the Mooney to get better airspeed.
Less drag.
Less drag, less parasite drag.
Next item on the checklist is drain the left fuel tank.
Okay.
So we drain the left fuel tank. no sort of water, sediment, or dust found.
Okay.
Let's put that back. Next item here is to check the leading edge of the left wing. Nicks cracks. Next item on the checklist is to check the pitot tube. Check, no blockages of the pitot tube.
Okay.
Next item is to check the stall horn in the stall horn.
Stall warning horn.
Free movement, no sort
Okay.
of blockages.
How can we check that? Make sure we have the sound, the warning.
This one is electrical in this airplane.
It's electrical, so if we turn on the master
Master.
switch, this thing will work?
Yes, okay. Check.
There's your check.
Next item is to check the left navigation light. Seems to be in good condition.
Okay.
Next item is to check for the left aileron.
Alright. They're
Free movement.
Free movement and normal movements, right?
We have the
Normal
nuts,
deflection,
we have
everything
the
is
nuts and bolts in
connected.
place. Next item is to check the left flap, condition
Okay.
of the left flap.
Go ahead and crawl under there.
All four connections seem to be tight.
Okay, and
Nuts
while
and
you're
bolts in
down
place.
there, inspect your gear door, gear, and your wheel, your tire. Okay. Looks in good condition. Yes, sir. All right.
No sort of obstruction, no leakages. Next item on the checklist is to check the elevators and the rudder.
Okay. Looks like
Seems to be nuts and bolts seems to be in
connections
place.
there. That says you're not supposed to push on it.
Rudder seems to be in place.
This you cannot move with your hands.
Nuts and bolts for the rudder seem to be in place.
Something that is unique about Moonies is the entire tail section moves. You see here, this opening, the whole tail moves forward and backward as you trim the aircraft, which means we're not required an elevator trim tab.
Okay. Check right elevator and right side of the rudder. Check. No handle. Nuts and bolts seem to be in place. Alright, check. So, according to the checklist, we're done for the pre-flight for today's flight.
Okay.
Let's go and fly.
The Mooney M20C's flight deck layout consists of a magnetic compass with the magnetic compass deviation card above it. On the extreme left we have the master switch, the ignition key and the magnetos. We have the gear locked and unlocked position lights, the red being for unlocked and the green being for locked. We have the airspeed indicator, the attitude indicator, the heading indicator, the vertical speed indicator, next to that the altimeter, an old-fashioned turn and slip coordinator, the primary OBS also with glide slope capability, and the secondary OBS or Omni bearing selector. The three knobs next to it are the ventilation, cabin ventilation, and the one next to that is the parking brake. We then have the yoke, which contains the clock as well as a push to talk button. On the left of the flight control yoke we have switches which include the auxiliary fuel pump, the main and emergency radio master, and we have lights. And on the extreme left we have the jacks for the headsets for the pilot. On top we have the fuses for the radios, Then we have the radio selector for navigations 1, communications 1 for selecting which radio set we want to use. We have the whole radio stack below, which consists of a brand new GPS. Below we have the second radio, which is comms 2 and nav 2. Next to it we have our EGT, or exhaust gas temperature. It's used for setting the mixture in the airplane when you're cruising about 3,000 feet. Next to it we have the transponder with the mode C capability, or altitude reporting capability. The Hobbs, or the Hobbs meter, which is a timer that tells you how long the master has been running for, or how long the electrical instruments have been running for. We have the tachometer from the engine. Below it we have the fuel flow gauge. Next to it we have the suction gauge. We have the left tank and right tank fuel gauges. We have the ammeter, the oil pressure, the oil temperature, and the cylinder head temperature gauge. The cylinder head temperature gauge is important for a constant speed or variable pitch propeller, as depending on the cylinder head you will either open or close the cowl flaps for optimum engine cooling. Next to it we have the prop control, which controls the angle at which the blades of the props are spinning. Then we have the mixture control. Next to it we have the throttle. Unlike the Cessna, the flaps on the Mooney are hydraulic, so the button or switch that you see closes the hydraulic valves, and then with the help of the steel rod you pump pressure into the hydraulic pump, so the flaps slowly go down with each pump that I put in. And when I'm ready for the flaps to come up, I just put the knob back up again and the valves open and the pressure is released, and you'll see the flaps coming up. To the left of that is another steel rod, which is for the gear. It's a big stick that goes from the bottom of the panel all the way down to between the seats of both the pilots. To release the stick, once you've taken off, you push the button on the left and you push down on the stick while twisting at the same time, and in one swift motion you push it down and lock it into its retracted position. We have two more knobs next to it. The one on the extreme top is the cowl flaps control, which open and close the cowl flaps, and below that we have the standby or secondary vacuum system in case the first one fails. We have two rudder pedals on each side. On the left you see that you have an extended metal sheet going above, which controls the brakes of the airplane. So the pilot on the left has brakes, but the pilot on the right doesn't have any.
Alright, we start with the before start checklist for our flight today on the Mooney. We've already completed the pre-flight inspection, check. Departure briefing. We'll be taking runway 22 for departure today.
Alright.
Climb out to about 1,000 feet, turn left, turn down south, and continue climbing to about 2,500. We start a few maneuvers, steep turns, a few stalls, turn around, come back, do a few touch and goes.
Okay.
Alright, landing gear check, down and locked. Cabin doors will be closed before departure. Seat belts are on, check.
On the right.
Passenger briefing is complete. Brakes are set. Fuel valve is selected on the left tank, check. Circuit breakers are all in, check. And avionics are off, check. Before engine start checklist complete. Engine start checklist. Master switch on, check. Beacon is on. Mixture is rich. Auxiliary fuel pump on for 3 seconds. 1, 2, 3. Check positive fuel flow. Fuel pump off. Pump throttle to prime. Already done that. Start the magnetos.
Okay.
Right.
Clear prop.
Clear prop.
Okay, stop the sequence for a second. And
Prime?
Use the electric primer again. Wait another couple of seconds. Alright, that's good. Let's try that again. Good start. Okay, oil pressure is coming up.
Pressure check. Cowl flaps open.
I'm doing the after engine startup checklist, which includes making sure that the cowl flaps are open.
Okay, cowl flaps are open.
Check.
I had extended the flaps completely for our pre-flight check, so I'm going to retract them now at the correct setting for takeoff.
Check. Flaps 15. Avionics on.
It's a good practice to make sure that radio frequencies are set before taxiing or before takeoff.
So we're going to use the speakerphone, so everything will be here.
Okay.
And right now we're going to go check the weather.
That's gonna be calm one.
My departure briefing consisted of me saying that we're going to be using runway 22. I'm right now listening to the weather in Venice, which is 119.275, to back up and make sure that my selection of runway was correct. Just like taxiing every other single-engine airplane, I usually add power to about 1000 RPM and start the taxi by including the brake check. I put full pressure on the brakes to make sure that the brakes are working.
Remember, I don't have brakes.
Brake check.
To check the clarity of my transmissions, I also do something that's known as a radio check. It involves me making a transmission on the Venice Unicom frequency 122.725, asking for a radio check. I get a response from fellow pilots who are flying right now saying that my radio does sound good. taxing that much. You don't really need to use wind correction angles for the ailerons. Because of the bungee type of suspension on the Mooney's landing gear, the taxi can be a little bumpy if the taxiway is not smooth or if the runway is not smooth. Overall, it's a different experience of taxiing the airplane, which always adds to the pleasure of flying a new airplane. Once I reach the designated run-up area for runway 22, I start the departure or takeoff checklist by doing the engine run-up. I start by adding power to the engine to about 2000 RPM and then checking the magnetos and different instruments.
And then we check the magnetos.
I'm also going to do a check with the prop control to see different indications on oil pressure, check the change in manifold pressure. The checklist includes me checking the magnetos of the engine to see if each magneto is functioning well.
I'll read it.
Check.
Okay, flaps.
Check.
Set.
Check. Take off.
Avionics on.
Check.
Transponder standby. Check. Timber set. Check. Taxi area is clear to the runway. Check. Testing the brakes. Check. Instrument lights. Check. Navigation lights. Check. Flight controls. Check. Elevator trim. Set indications right here.
I'm now setting the trim for takeoff. The gauge for the trim is next to my right leg. It's hard to see from this angle.
Then the pre-takeoff checklist goes on. Right, so the bump stays on, it goes on for takeoff. This one will off. Okay. Now we completed the taxi takeoff checklist, so we're ready to go. Check. Remember, after takeoff, when you bring the gear up, push these doors down,
unlock it.
use your lock.
Yeah,
Okay,
lock.
I'm going to flag here.
Alright.
So say what it was good to you. Yeah.
Morning.
It's a good practice to listen and look out for traffic. I'm on 122.75, which is the Venice Unicom frequency, and I'm making my radio calls telling everyone about my departure. I've also looked to the approach and the departure side of runway 22 to make sure that I'm clear of any traffic.
Okay, approach sector is clear. Yeah, move it.
Once I go full throttle, I make sure that my hand is on the throttle. The vibrations of the airplane, especially the Mooney, can sometimes get the throttle to slowly slip back a bit. The stall horn came on at takeoff because I rotated at a speed slower than required. I correct for it immediately by putting the nose down a bit so I can increase the airflow over the wings. The airspeed indicator on the Mooney is different from the Cessna airplanes that I'm so used to flying right now, so I misread it thinking that I'm at a faster airspeed than actual. This just shows how familiarization of a new airplane is important. It takes some effort to put the gear up, so that's why I give Arna the controls. Once I know that the gear is retracted and locked up, I take the controls again and start my turn to the south so we can start our maneuver. Unlike the Cessnas or most smaller general aviation single-engine airplanes, the Mooney, being a variable pitch or constant speed propeller, has a specific climb setting for its engine, which includes setting the manifold pressure and the RPM of the prop. GPS, or a global positioning system, is a big advantage. It gives your position, your airspeed, your actual heading that you're tracking, and your ground speed as well. Some of the newer GPS systems also have an inbuilt radio. The more higher end ones have TCAS, which is traffic collision avoidance systems, and terrain avoidance systems. Our Mooney here has terrain avoidance system in it. Right now, approximately 110 miles per hour, or about 19 knots, climbing at 500 feet per minute. We've reached an altitude of 1,800 feet, and we're going to continue climbing. Practice area in Venice is to the southeast and the northeast of the airport. The airfield that you see on the tip of the wing is Buchan Airfield. It's a grass airfield about 7 miles south of Venice. We usually use this airport for practicing what's known as soft field landings. hard to see the manifold pressure gauge and the RPM or the engine tach from where I'm sitting, so you see me putting my head back quite often to see the gauges clearly. Leveled off at approximately 2,500 feet, flying at an airspeed of 115 miles per hour or 100 knots. Is the wheel for the nose up or nose down trim. I use it for relieving the pressures on the control yoke. I'm not going to demonstrate slow flight or flight at minimum controllable airspeed. It involves me first putting the gear down and then putting the airplane in a landing configuration. Put the gear down and the flaps are extended completely. I'm holding the altitude and I've reduced the power so that my airspeed slows down. As the airplane slows down further, I have to start adding more power to maintain altitude. I've slowed down to about 60 knots right now, or 70 miles per hour. After I'm done demonstrating slow flight or minimum controllable airspeed, I'm going to demonstrate a power off stall. The moment I get the first indication of a stall or the stall horn comes on, I pitch down, I add power, and I put one notch of flaps up. I also put the gear up. You'll notice the red light in front of me, which denotes that the gear is locked up. I get a thumbs up for Arla for my good performance on the demonstration. I'm at the entry heading, at the entry altitude, as well as the entry airspeed. I'm now going to demonstrate and perform steep turns. My pre-maneuver checklist is a mental checklist. It involves checking out for traffic, 45 degrees and looking outside for traffic and visual references. Once I'm established in the turn, I add a little bit of power. That's because of the loss of lift during the turn. I want to keep the same altitude, so to compensate for the lost lift, I add about 100 RPM. I start my rollout at about 20 degrees before my entry heading. Radar tells me that it's now time to start going to the left, looking outside again for traffic and for other visual references. I've gained some altitude during my left turn. I can always compensate for it by releasing or adding elevator pressure to the flight controls. We're now heading back to Venice, and I've started my descent. It's now time to do the approach briefing and the approach checklist. It involves us discussing the use of the runway and the entry for the traffic pattern, as well as checking the weather in Venice to see for any wind changes. Arna has given me instructions about the correct entry procedure into the traffic pattern for the runway in use. Rather stable airplane in cruise flight. You don't really have to trim it a lot, or you don't have to make a lot of effort to keep it at altitude. I'm going to be overflying runway 22 at about 1,500 feet, flying outbound for about 2 minutes, and then do the procedure turn to enter the right downwind for runway 13. At Venice, runway 13 is the only runway which has a right-hand traffic pattern. When you go from the Cessna 152 to the 172 to the Mooney, it's definitely a much faster airplane. This airplane is the rocket of single-engine airplanes. It's the fastest single-engine airplane in its category. Having a constant speed or a variable pitch propeller helps you get all the power out of the engine and you don't lose anything. The airplane, once you get it to your cruise altitude, will not move. It's how it's built. It's a cruise airplane. It's what I've heard from a few people. You don't have to trim it too much. Once it reaches your desired cruise altitude, it will stay there. At After flying for about 2 minutes outbound, I'm going to start my turn to the left to make a teardrop entry, which is recommended for entry into the midfield downwind for runway 13. I'm also going to start a gradual descent to about 1,000 feet, which is standard traffic pattern altitude at Venice. One of the advantages of carrying out a teardrop entry for a traffic pattern, it sets you up for a good 45-degree entry into the downwind. It also gives you a good view of any traffic which is in front of you or behind you. The Mooney is spacious if you're flying with two pilots. Of course, if you have someone sitting in the back, it does become kind of cramped for the person on the back, but it is a really comfortable airplane. The procedure for putting the gear down on the Mooney is to put it when you're midfield downwind for a little runway. Since I'm a beam the numbers, it's now time for me to slow the airplane and begin my descent down to turn base. You see that I've already put in one notch of flaps. I'm keeping my eyes out on the runway as well as the final approach side of the runway to make sure that there's no traffic. Arna points out the instruments and the knobs to show that I'm set for landing. The basic landing checklist on this sort of an airplane includes making sure that the prop control is full forward, making sure that the gear is down, the flaps are down, and that I'm at a good airspeed for landing. Once I'm above the numbers, I go idle and let the airplane glide down the runway. Since this is a new airplane for me, and since I'm sitting lower than I do sit in the Cessna airplanes, landing was a slight challenge. Really nice airplane, especially for training. It gives you a good idea of what a constant speed prop feels like before you get into the multi-engine airplane. Venice, we have runway 13, which is the only traffic pattern which turns to the right. The takeoff was rather smooth and at a good airspeed. That's why of course you didn't hear the stall horn and you didn't see me put the nose down. I'm now turning right crosswind for runway 13. The recommended altitude for starting your turn to crosswind is approximately 500 to 700 feet. Florida has some of the best weather to learn how to fly and to fly generally. This is a perfect and a beautiful day for flying. I've already reached midfield downwind, so you saw me put the gear down. I've already begun my descent and I've slowed down as well. I'm turning right base for runway 13 at approximately 700 feet. The Mooney has just one indent on its flap position indicator, which is takeoff position, and then it has full flaps. So there's no set degrees that you have for the flaps in the Mooney. So you really have one setting that you can crank for just for takeoff, and then you can crank in probably 2 or 3 more cranks to put it into the full position for your landing. On final approach, you want to be at a speed of about anywhere from 75 to 80 knots. Flying a Mooney for the first time is overwhelming because of the many more things that you have to keep in mind and look out for, including the gear, most importantly. When you're flying a Cessna 152 or 172, the gear is fixed down, so you don't have to worry about it. With the Mooney, you have to make sure that you're always on top of your checklist to make sure that you don't forget anything. While you're choosing a flight school, you want to make sure that you know the instructor to student ratio. When an instructor has a few students, he is able to give you more personalized attention. Things like financials are, of course, always there. Having contractual training probably helps you out because it gives you an idea of how much you will actually end up spending for your training, depending on the course that you've chosen. While you're looking for a flight school and once you see their prices, one thing for you to remember is that it's not about the money, but it's about the quality of training that you get. You should actually consider spending more if you know that the quality of training that you're getting is much better. So it's more important to look for quality more than the price of the school. See the number of airplanes that FFTC actually owns. The ones that you saw right now were Cessna 152s. The two bigger white airplanes are the Cessna 172s, and the one to the far left is the Piper Seneca, one of two which FFTC owns. The engine shutdown always involves putting the avionics off first so that we don't damage the radios. The next step is to pull the mixture so there's no more supply of fuel to the cylinder of the engines.
Magnetos off. Navigation light, we never used this.
And once the prop stops spinning, it's important to make sure that the magnetos are off. In case there's any fuel left inside the cylinders, the engine can start again.
Rocks checklist complete.
Checklist complete. Good flight.
Yeah, it was a good flight.
How did you feel about the experience flying a complex aircraft today for the first time?
The landing gear was a bit difficult for the first flight, but it was nice. It was a different feeling, different airplane. It was good.
You want to make sure that you have enough airspeed
Okay.
before leaving the ground and leaving ground effect.
Ground effect, okay.
Okay, it's a little bit bigger aircraft and it will fly, if you let it, it will fly early. As you keep the nose up, when the airplane rotates, release a little bit of back pressure, relax a little bit on the yoke, and build up some airspeed before you use the final attitude that we're going to use to climb to our first 1,000 feet.
Okay.
Okay?
Yes.
You noticed that the stall warning came on, or almost came on, and the airplane felt a little bit unstable. The other thing I noticed was that on the downwind, we got a little bit behind the aircraft. That is normal. There's more things you have to think about right now. We were not, until now, we were not used to have to lower our landing gear. So this is an additional action that we need to take to get ready for a landing. You can extend the landing gear at any point coming in for a landing, but the longer you wait, the more busy you will get at the final stage.
Okay.
Okay? So if you're 2 miles out and you want to extend your landing gear, that's fine. On the 45-degree angle or leg towards your downwind, if you want to extend your landing gear, that's fine. Some people use the landing gear to produce more drag early on or sooner to lose altitude. Your flaps you use just like we did in the 172, 152 in the other aircraft. You know, being the numbers, you probably already have 10 degrees of flaps, and then somewhere on base you add to that, and then on final you can go to full flaps if you like.
Okay.
All right. Remember, it's a race car. You sit very low. You noticed that today.
Yes.
So it is normal initially for people to flare a little bit high, but you also noticed, because we flared a little bit high and we touched down a little bit harder than you and I like, how hard it feels. So you have to tell yourself in the future to get a little bit lower with your flare before we stall the aircraft over the runway. Okay. So these are some of the things that I noticed. I think you flew the airplane beautifully for our first flight. So keep going like this.
All right. Thank you.
All right.
Hello, my name is Arne Kruthoff. I'm the owner of the Florida Flight Training Center. The Florida Flight Training Center is in Venice, Florida, and I started this flight school in 1992. I flew everything from little Cessnas to King Airs and DC-8s around the world. Today I have almost 12,000 hours of flight time. A lot of times people ask me what it takes to become a pilot. I would recommend go to the nearest flight school and find out. Most flight schools around the country, around the world, have competent people that can talk to you and tell you about all the advantages that aviation brings. So go out to the nearest flight school and find out for yourself. Once you think you have chosen that you want to become a pilot, let's first think about where we should go, which country, which area to pick a flight school. I think the most important thing is to look at the quality of the flight training at that school itself. Secondarily, I think the infrastructure is very important, and the availability of the material and the quality of the teaching itself. If your choice is to become an airline pilot, it is important to find a school that maintains airline standards. A big mistake that people make once they start looking for a flight school is they choose the cheapest flight school or the school that offers cheap flight training. The problem with this is that flight training is not cheap. The avgas or the fuel that we use for our aircraft and the whole support and infrastructure in and around the school, these are expensive things. To maintain quality, to maintain high standards, this costs a certain amount. People in this industry that are trying to bring in students to their flight school by offering not realistic prices for their aircraft and training are not the schools I would recommend. To put this a little bit more in perspective, let's assume you have the choice between two schools, and the school you like better has a training cost that is $10,000 higher than the other school that you don't like so much. $10,000 is 2 weeks or 3 weeks salary by the time you become a captain, and can quickly be earned back once we are professionals. A school with poor airplanes that have poor maintenance, bad teachers, or a poor infrastructure, perhaps has bad meteorological conditions for a big portion of the year, will cost in time so much more than these $10,000 that the choice should be to go for the school that is maybe a little bit more expensive but will make you smile and happy every day you come to flight school, and will actually give you a good chance to go into this industry, be able to earn your salary without too many frustrations. The typical course here at the school would be somewhere between 6 and 8 months. This will take you from the private through the instrument through the commercial level. Of course, one would have to do other things after that to be able to get a first job with an airline. But typically after a year and a half, perhaps with a flight instructor rate in teaching for some 4 or 5 hours a day, this person would become eligible and would have a potential chance to get hired by a commuter or a major airline. Which means within a year and a half, this person could start earning money, executing the profession, the job that they dreamed of when they were younger. Another piece of advice to all of you out there, if your choice or your dream is to become an airline pilot, don't let the economy or the market discourage you from going to flight school. The typical aviation cycle is 6 to 7 years, where lots and lots of pilots are needed and then less pilots are needed. But the population is growing rapidly. Aviation is still the most popular and becoming more and more popular way to travel. Therefore, pilots will be needed, and pilot shortages will become an acute problem again in the near future. If you're thinking about learning how to fly in the United States, these are some of the beautiful things in this country. We have an incredible infrastructure. Every town, every village in this country has its own runways, its own airports where we can fly, and airports that we can use daytime and nighttime. These airports at nighttime have lights that we can activate while being in the air without paying anything extra. Landings, we can make as many as we like, as many as we think are necessary to become good pilots at no additional cost. In the United States, we don't pay for the service of airways, the use of airways. In the United States, we don't pay additional money for practicing an instrument landing procedure. This is the only country where services are for the pilots, and the whole system is designed and developed to support pilots. This is beautiful, this is unique. Add to that the beautiful country itself with its beautiful weather in most of the country, and I think America is an excellent choice to learn how to fly. As a recommendation to the parents of all those youngsters out there that are dreaming about becoming a pilot, that maybe are afraid to talk to you and tell you that they want to become a pilot, please don't discourage them. Please allow them to go to the nearest flight school, to the nearest airport, and let them try to fly an airplane. And if this puts a great smile on their face, and if you see that there is this dream, find out the possibilities and what it will take so your son, your daughter can become a pilot. Often I get young people contact me who wear glasses, who are maybe overweight, short, tall, or maybe feel that they are not made for this profession. What we need to remember is, in aviation and in the pilot world, we look for stable, reliable, and loyal people who don't make mistakes once they're sitting in the cockpit of an aircraft. But for this, you don't need to be a Superman. So every average person coming out of school has a fair chance to fulfill this dream.
Great.